Alright guys, welcome again. We begin with question 21. If you're new, make sure you watch from question 1 to question 6, then question 6 to question 10, then question 10 to question 20. Now we are beginning with question 21. Alright, I will indicate all those links in the description of this video, so that if you can't find the links in the channel, then you just get directly to the description of this video to get those links. Alright, question 21. Here we go. Jesus Christ, what is this? The integral from -1 to 1 of all of this. Alright, 0. Yeah, 0. Even without thinking, because basically examiners cannot test this. They are testing if you know that the integral of an odd function from a negative value to the positive of that value is 0. Alright, that's just a definition. Now I'm going to write that if f is odd, right? If f is odd, then the integral from -a to a of f of x, where f is continuous in the interval -a to a, is equal to 0. Alright, and let's talk about even. And if f is even, then the integral from -a to a of f of x is equal to 2 times the integral from 0 to a of f of x. So these are just, so if f is odd, then that integral happens, and if f is even, then this integral happens. So we just have to determine in this case if f is odd or f is even. F of x in this case is equal to, let's go back, x to the 9 minus x cubed, x to the power 9 minus x cubed. Then later you have plus tan x on, plus tan x divided by 1 plus x to the power 4. Was this all square that I saw? Yes. So let's look for f of -x. Alright, that's the first thing to do. F of -x is equal to, if I raise -x to the power 9, since the power is odd, I'll have -x to the power 9. Alright, then minus, if I raise -x to the power 3, since the power is also odd, I will have -x cubed, just like that. Now the tangent function is an odd function, so I'm going to have here the tan of -x will give me the tan of x. Now if I raise x to the power 4, if I raise -x to the power 4, I will just have x to the power 4, because the power is even. This negative sign will go out. Alright, okay, this negative sign and this negative sign will in fact, let us factorize negative from all terms. If I factorize the negative sign from all the terms, from here I'll just be left with x to the power 9. Right, I'll be left with x to the power 9. If I factorize this negative sign, I'll be left with what? -x cubed, so minus x cubed. If I factorize this negative sign, I'll be left with positive than x over 1 plus x to the power 4 all squared. But you realize that what is in bracket is just f of x. Okay, so it means that our f of -x is equal to -f of x. Hence f is odd. And if f is odd, then clearly the integral from -1 to 1, because a is -1, is equal to 0 without any doubt. Now the question you should be asking yourself is, can you integrate it without bounds? What if the bounds were not given? When you ask yourself that question, you tell me your answer. I don't want to think about integrating it without bounds, please. Alright, 22. So this guy is option B. Let's go and indicate that it's option B. 22. The general solution of the differential equation where p and q are constants is x equal to what? The squared x by dt squared plus 9x equal to 0. The squared x by dt squared plus 9x equal to 0. First things first, we have to get the auxiliary equation. Okay, auxiliary equation. Now I'm going to have m squared plus 9 equal to 0 because I'm just replacing this man here with the parameter squared. Then the constant, the what is not having any differential with the parameter with just a constant. So from here we are going to have m squared to be equal to minus 9. So what will be m? Plus or minus 3i, right? Actually 0 plus or minus 3i. Okay, so what is x equal to? Roots are complex, so the general solution will be in the form. First of all, you have to recall, let me recall, that if m is equal to a plus or minus bi plus or minus bi, then your x will be equal to, since it's in terms of t, right, your x will be equal to e raised to the power e raised to the power small a t, the cosine of bt, maybe plus epsilon. This is just a general solution. Okay, or you could use sine, or you could use sine instead of cos. You use sine, you don't have any problem. Okay, so a is the real part of my roots and b is the imaginary part. Here my real part is 0 and my imaginary part is 3. So it therefore means that in this case we have x to be equal to a constant, e raised to the power 0 t. So I just remove it from there. The cosine of my b is 3, so 3t plus epsilon from any constant of your choice, or we use sine. Okay, here we have 3. Alright, so all we need to do is to check how the answers are. A and B are wrong already. P cos 3t plus lambda, correct. 9 wrong because our imaginary part is 3, right? So option C is correct. Option C. So if I want to write in the form given, it is P, yes, or P. So then just put a P there. For convenience, 23. Which option will be correct? Let's see. The mean value of cos 2x in the interval 0 to 2. So mean value is equal to, so if I want to find the mean value in an interval a to b, I'll have 1 over b minus a from a to b integral of a function to x. That's the definition of mean value. So in this case, the mean value of cos 2x in that interval will just be equal to, my interval is from 0 to 2, so 1 over 2 minus 0, then the integral from 0 to 2 of cos 2x, the x, that is it. So what do we have? We have 1 over 2. Now cos 2x, right, is the same as half times e to the 2x plus e to the negative 2x. Okay, so this gives me, the halves will give us 1/4. When you integrate e to the 2x, you just have half e to the 2x. When you integrate e to the negative 2x, you have negative half e to the 2x. We are doing that from 0 to 2. Okay, so this will be equal to You can factorize this half and this half. You multiply with 1/4, you get 1 divided by 8. You replace x with 2, you're going to have e to the power 4 minus e raised to the power -4. That's for the upper bound. Now we need to subtract the lower bound. We need to replace x with 0. We are going to have here 1 minus 1. The lower bound will give us 0, so everything becomes this. So we just have to check if the answer is there. Option B is correct. 1/8 times e to the power 4 minus e to the -4. Option B. Right. Let's move on to question 24. Yeah, question 24. Which option will be correct? That's the very first question I asked myself when I arrived at MCQ. Alright, a curve is given in a Cartesian form by the equation x squared plus y squared plus y equal to x squared plus y squared to the power half. What's the polar equation? X squared plus y squared plus 2y. So we have x squared plus y squared, x squared plus y squared plus 2y equal to x squared plus y squared raised to the power half. So in one of the videos, I think I gave you guys a conversion. So x squared plus y squared is r squared, alright, plus 2. What is y? Y is equal to r sine theta. I gave you guys this conversion in one of the videos, equal to x squared plus y squared is r squared. So we have r squared raised to the power half. We just give you r because r is positive. So this means that we have something like r squared. We have r squared plus 2r sine theta equal to r. Now we can subtract r sine theta on both sides. Okay, we have r squared is equal to r minus r sine theta. R minus r sine theta. Okay. Let me complete up here. So this means that we can divide both sides by r, alright, because r cannot be 0, so we can clearly divide both sides, because this r squared is the same as r times r. If I factorize r from the right hand side, I will have here 1, I will have here minus sine theta. Okay, and if I divide both sides by one of the arrows, you realize that what is the answer? R equal to 1 minus sine theta. So r equal to 1 minus sine theta is the correct option. Oh, there was a 2 here. Oh god. So here we have 2, right? I'm sure some of you are already saying that, oh, you have made a mistake, Anyways, that's life. So we have r equal to 1 minus 2 sine theta. There's one check. Option B, r equal to 1 minus 2 sine theta. Okay. We are left with 5 questions to complete this video. Question 25. Which option is correct? So let me see if I can guess with my eyes. Okay. If the asymptotes to this hyperbola are perpendicular, then the value of a is, in fact, the asymptotes, if they are perpendicular, in fact, the asymptotes to a parabola are basically the oblique asymptotes. So let me just give you a general case. If you have the parabola x squared over p squared plus minus y squared on q squared equal to 1, the asymptotes are y equal to plus or minus q divided by px. Here's a definition of all the asymptotes. Okay, so in this case, our asymptote will be y1 equal to, you see that, let's go back to the equation, x squared on 16 minus y squared on a squared. So our hyperbola here is x squared on 16. 16 is 4 squared, okay, minus y squared on a squared equal to 1. So what is p? So p is equal to 4, right, if you're comparing. Y cube is equal to a if you're comparing. So the asymptote will be y1 equal to, if we take plus q on p, so it is a divided by 4x, and the next asymptote will be y2 equal to, we now need to take minus a divided by 4x. Now if these are lines, right, and the gradient of the first line is a over 4 and the gradient of the second line is negative a over 4, so if the asymptotes are perpendicular, what's happening to perpendicular, then what happens? The product of the gradient is equal to negative 1. So a over 4 times negative a on 4 is equal to negative 1. So all we have is that a squared will be equal to 16, because the negative will cancel the negative. 4 times 4 is 16, cross multiply. So if a is equal to 16, therefore means that if a squared is 16, means that a is equal to plus or minus 4. So either plus 4 or minus 4, those are the two values of a. We go back to the equation. So we are going to take just plus 4, but we are supposing that a is positive. So a is equal to 16. So a is equal to 4. So it's a rectangular hyperbola actually. Yes, a rectangular hyperbola. So that was another way of looking at it. Okay. Anyways, so a is 4. Yep. Option Z. Option Z. So if a is 4, you realize that this is just going to be x squared on 4 squared minus y squared on 4 squared equal to 1. Let's plot and see, and then I plot the asymptote and show you. Let's not be that I was cheating. X squared divided by 16 minus y squared divided by plus or minus 4 squared is 16 equal to 1. Alright, here is my parabola. Now if I draw y equal to, we said it is plus or minus q here is, so is plus or minus, what is it there? So plus or minus q on p, so a over 4 and negative a over 4. So y will be equal to our a is basically 4, so is x is equal to y is equal to x, and we have y is equal to negative x. You see, they are perpendicular. That's what we call this a rectangular. No, this is not a rectangular. It's not rectangular. It's not rectangular. It's not a rectangular hyperbola. Sorry. But anyways, this is just a plot. Okay. Here's just it. Those are the two asymptotes to the curve. Alright, so like we said, option D is correct. Alright, question 26. Given that a and b are two vectors, which of the following compound statements is true? Option A, if a dot b is 0, then a dot b is equal to 0 if a is perpendicular to b. We end there. If two vectors are perpendicular, then their dot product is 0. So 26 is option A. Without wasting much of your time. Alright, 26, option A. 27, which option will be correct? 27. Okay, we need to go up. For what value of p is this matrix non-invertible? Non-invertible means that there is no inverse. Invertible means there's an inverse. So non-invertible is a negation of invertible, so there is no inverse. And when there is no inverse, then the determinant is 0. So we need to find the determinant equal to 0, and then we find the value of p. Okay, so the determinant of the matrix. So the matrix, we have 4 3 3, 4 3 3. Here we have P 5 6. That's provided I saw well, and then 6 7 9 equal to 0 means that if I keep 4, right, I'm going to have cover this, I have 45 minus, what is 7 times 6? 7 times 6 is 42. So I have 45 minus 42. When I go to cover 3, I cover this, I get 9p minus 36. 9p minus 36. When I go to cover 3, put a positive sign, I get 7p minus 30. 7p minus 30 equal to 0. So this means that this man gives me 3 times 4 is 12. When you multiply here, we have minus 27p, negative 3 times negative 36. What is that? Negative 3 times negative 36. I think it is 108. I'm sure. Let's see. Let me just be sure that the answer is correct. 3 times 36. Okay, 108. Perfect. Now 3 times 7, 21p. 3 times negative 30, negative 90 equals to 0. 12 plus 108 is 120. 120. So I'm just going to remove this one. Alright, I remove this one. 120 minus 90 is 30. If I'm turning to the right hand side, it becomes negative 30. When I add these two things, what do I have? I have negative 6. Okay, so negative 6. The two negatives can cancel and we get p to be equal to 5. So 27, p is equal to 5, option A. Okay, 28. 28. A necessary and a sufficient condition to show that a group is not abelian is, let us see, is it closure, is it existence of identities associative or commutative? Anyways, an abelian group is a group that is closed, inverse of an element exists, identity element exists, it is associative, and it is commutative. Alright, those are the 5 properties of an abelian group. So which condition is necessary and sufficient for the group not to be abelian? If you are abelian, okay, then those 5 properties should hold. If you are not abelian, if one of the properties fail, then we can conclude. But this time around, we are looking for a condition that is at the same time necessary and at the same time sufficient, which means that if you prove that property, then you'll be able to determine if the group is abelian or not, right? So in this case, if you prove that property, you'll be able to prove that it is already sufficient to say that the group is not abelian. So the answer is commutative, right? It's commutative, because if you're able to prove commutativity, you can already conclude, because for you to be an abelian group, you are first of all a group who is commutative. So an abelian group is a group that is commutative. So if we are able to prove commutativity, we can use to conclude if you are abelian or not. So commutativity is both necessary and at the same time sufficient to show that the group is not abelian. Alright, so if you prove the commutative property and it is true, then the group will be abelian. If it is not true, then the group will not be abelian. So 28 is D. The solution of the system of congruences this is, so most of you, when you see this, you use Chinese remainder theorem. Fine. I can't remember that, so I'll use something else, because the theorem has you need to do something or the rest. Anyways, I cannot remember the formula of the theorem, so I'm just going to use something else. But you can use your Chinese remainder theorem if you wish. Alright, so we have x congruent to 1 mod 2, x congruent to 2 mod 3. So x congruent to 1 mod 2, what does it mean? It means that x is equal to 1 plus 2t. That's the definition, converting the congruent equation into a linear equation. Now I'm going to substitute this x in the second equation. The second equation is x congruent to 2 mod 3. So I have something like 1 plus 2t congruent to 2 mod 3. This just means that I'll subtract 1 on both sides. 2t will be congruent, and subtracting 1, I can just take 2 minus 1 without any problem, because this 1 is the same as 1 mod 3. So 2t is congruent to 1 mod 3. Now what about t? So t will be congruent. Now if 2t is congruent to 1 mod 3, it just means that we are looking for the inverse of 2 in mod 3. Which number will I multiply by 2 and I divide by 3 to have a remainder of 1? I think 2 times 2 will work. 2 times 2 is 4. 4 divided by 3, the remainder is 1. So t will be congruent to 2 mod 3. Okay, now if t is congruent to 2 mod 3, it means that t is equal to 2 plus 3 times maybe s, right? If we are converting into linear, so it means that x will be equal to 1 plus 2 times, what is t? 2 plus 3s. So we have 1 plus 4 plus 6s, which means that x is equal to 5 plus 6s. Now if I convert it back to a congruent equation, I will have x is congruent to 5 mod 6, because if I'm converting this back, I will have 5 plus 6s. Now time to check the answer. Option D, 5 mod 6. $29. Oh, 30. Wow, last question already. Interesting. Z cube is negative 8. What are the solutions of z? Okay, so z cube is equal to negative 8. It means that so the real solution is just I'm going to call it z real. Okay, it's just a cube root of negative 8, because they are normally supposed to be 3 solutions. Okay, 1 real and 2 complex. So the cube root of negative 8, and that cube root is negative 2. Now if z equal to negative 2 is a solution, it means that z plus 2 is a root. Now we can do long division to get the other root, then we solve the other root equal to 0. So I've gotten that negative 2 is a root. It means that z minus negative 2 is a factor, which means z plus negative 2 is a factor. So it's going to do long division here. This is too broad for me to do. Anyways, I will do synthetic division. So for synthetic division, we have to draw a line. My equation is basically the same as z cube plus 8. So I'll put the coefficients of z cube 1. I'll put the coefficient of z squared 0. I'll put the coefficient of z 0. I'll put the coefficient of the constant 8. Then on this other side, I'll just put my negative 2, which is a root. Now the next thing to do is that I'll bring down 1. Okay, I'll bring down 1. Then I'll be doing, I'll kind of be multiplying and then adding. So wait, let me take it down. In fact, you can do long division. This is what I'm trying to say. I'm saying take z cube plus 8, take z cube plus 8, and divide by z plus 2. Yes, so I'm doing what we call synthetic division, where I write the coefficients of the numerator from in decreasing order: the coefficient of z cubed, the coefficient of z squared, the coefficient of z, and the coefficient of the constant. Then I solve the denominator equal to 0. I find the roots, then I place it here. Then I start by dropping down the first guy, then I start multiplying and adding. Okay, so I drop down 1. Now the next thing is that I will take 1 times -2. It will give me -2. When I add 0 to -2, I will get -2. I will take -2 times -2, I will get 4. When I add 0 to 4, I will get 4. 4 times -2, I will get 8. No, I will get -8. When I add -8 to 8, I will get 0. This is a remainder. So my other factor will be z squared minus 2z plus 4. So if you do long division, you're going to get that. So this is equal to z squared minus 2z plus 4. It therefore means that my z cubed plus 8 is equal to z plus 2 times this other factor. Alright, so I was just running away from long division because it's too long indeed. Okay, so if I solve z squared minus 2z plus 4 equal to 0 using a quadratic formula, I will get z to be equal to negative b, which is 2, plus or minus the square root of b squared. What is b squared? 4 minus 4ac, all divided by 2a. So we get negative 2 plus or minus the square root. This man is negative 12, so we have 12i. Okay, and root 12 is the same as 2 root 3. The 2's can cancel, and we get 1 here, cancel here, and we get 1 in the denominator. So this is what we have, negative 1 plus or minus I root 3. So there are 3 roots, so we have z equal to negative 2 and z equal to negative 1 plus or minus I root 3. So let's go and check the answers. Negative 2, negative 1 plus or minus, I sure I've not made a mistake. No, it was supposed to be just positive, and the one who put the negative 1 here. The effects of sleep. Alright, so we have 1, right, plus or minus I root 3. So 1, negative 2, and then 1 plus or minus I root 3. So option A. My 30, option A. Alright guys, you have come to the end of this tutorial session. See you guys from question 31 to question 40 in the next video. Stay tuned.